We do have a very exciting talk with you today. We're going to be talking about software architecture, like I mentioned, and it is a very much, I want to say like this presentation is packed with a lot of good information. But if you do have any questions, please feel free to use the chat for any questions. We can take them as they come, or you can simply, do have a Q&A at the end of the presentation. And yeah, like Shiki mentioned, you can definitely come off camera and off mic, and at any time you can like virtually raise your hand, and Shiki will definitely make sure that we get to you. I'll just give it a little bit more time. Oh, and this is being recorded, like Shiki mentioned. So we'll do a little bit of editing. Okay. No problem. Okay, so I think, Shiki, if you can hear me, and I think everybody else can, why don't we start? Awesome, perfect. So we got the thumbs up from Shiki, so now we are ready to start. Yeah, so like I mentioned already, welcome to an introduction to software. My name is Gonzalo Vasquez, and I just wanted to first take the time to thank and acknowledge Shiki for all the hard work that she has put together, putting together the Toronto chapter for Code Academy. And, this is definitely something that me personally, I love to talk about, which is like architecture. So I really, this presentation is kind of meant for you to kind of, get your feet wet into software architecture, what it is, and even if you're planning to follow your career path into software architecture, this will also be helpful. So a little bit about myself. Like I mentioned, my name is Gonzalo, and to my right is my work experience. So currently I'm the principal architect at a company called TELUS Digital. But as you can see before that, I do have an extensive experience in architecture. Things that I really do enjoy apart from coding are improv. I do host a meetup called Life Questions Academy, which at the end I'll provide you a link to this deck with all the links. In there we talk about audacious questions and conversations. I also like to do painting, rock climbing, dancing, singing, coding, of course, and writing. So a little bit about so that's mainly myself. Like Shiki mentioned, most of my experience is in the tech industry, mostly in financial companies, in banking institutions, as well as with small, smaller startups, and now working at a telecom in Canada. So this is the agenda that I have prepared for you today, and we're really going to talk about why we need software architecture. Software architecture is one of those things that a lot of people sometimes either have a really good idea of what it is or don't really know. We'll talk about what is software architecture. We'll talk about architectural principles and architectural patterns. Finally, I have a case study for you. And in the case study, it is meant to be interactive. So definitely I'm going to be, coming off full screen. I'm going to be asking you questions, and we're almost going to mock a little architectural session in this case study I have prepared for you. And like I mentioned, we'll have a Q&A just close to the end. So before we kick off the presentation, if you don't mind, on the chat, just telling me a little bit about your what role you have today in technology. Either are you beginner, are you intermediate, or are you senior? I would love just to get a little sense of our attendees of where you are in the scale. So again, those three options: beginner, intermediate, or senior. Perfect. Seeing Shamila, beginner, Jason, Sherry, Devon. Perfect. Thanks so much. Peter, Jeff, network engineer. Okay, beautiful. Perfect. So we definitely have a lot of good beginners, which I'm very happy. Intermediate, Rafael, thank you so much. David, Jim. Thank you so much. I really feel that, this content prepared for you, it is a beginner, but it is definitely a little bit dense, right? So we'll try to make it, again, as interactive as possible. And we have Shiki here to support us the whole way. So I really like to start every good presentation with a learning outcome. So by the end of this hour together, this is what we're going to learn. After this session, you'll be able to identify architectural decisions during your process. You will be able to understand common patterns and principles and when to use them. And finally, you will be able to analyze and provide high-level feedback on an architectural diagram. The reason why these three learning outcomes are very important is because throughout your career, you need to be able to know when you are kind of stumbling into a decision that really is going to have ramifications with your developers. And you also need to understand that when you bridge into software architecture, you're definitely not starting from zero. There are a lot of great patterns and principles out there that have been helping, that are helping us in order to build software that is scalable and reliable. And finally, having that really good lens to analyze a problem, have a diagram, it really presents a really good opportunity as you progress in your careers. So we'll start with the most basic question. Why software architecture? So when we write application, any kind of application, we usually have an idea of, who's it for, the amount of users that it's going to be, that it needs to support, the device that it needs to run on. All these are architectural decisions, and very similar to, designing a pair of sunglasses or a rocket ship. Architecture helps bridge design, engineering, and business stakeholders together. So the way that I really like to think about architecture is, in a sense, you have a business problem, and it is the role of the architect to take this business problem and put it into words that it can be technically solved. So, and the way we do that in software architecture is we use patterns. We use patterns to solve unique and challenging problems. The great thing about software architecture is that a lot of the problems that we'll stumble upon, they have been solved, and there are proven patterns. It is just a matter of using the right pattern for our business needs and for the intended use of the application. So a little bit more, we'll talk more about, the why behind architecture, but knowing that architecture is really about making those decisions and acknowledging those decisions that you're making, as choosing a database, as choosing, which programming language you're going to write your app in. All these, like I mentioned, they have implications on the person that is going to work on your application. It has implications on your user, and it has implications in the organization. So it is very important that architecture really plays a pivotal role there, because again, it really helps us when we're building software to bridge design, business, and engineering together. So that's really, in my mind, the biggest why of why software architecture is helping us today. Then we're going to talk about what is software architecture. So when we think about software architecture, we can really divide it into two parts. The first part is software architecture, and software architecture really serves as a blueprint, almost a map of your system that is allow any technical person, any developer, at a glance of a diagram, they're able to know how your system works. They're able to know what is the type of data that your system requires. It's able to know where your system is deployed. So a lot of these decisions, we have a network engineer with us, right? But along with team members, all these are decisions that are taken together and taken into account because they all have repercussions. The second aspect is software design. Software design is a little bit different than software architecture because software design talks about the plan. It is a plan on how we're going to make sure that we fulfill all the requirements of our system. So if I could put it in like the easy way is software architecture is our blueprint, is our map, where our software design is our plan to get there. So both of these tools, we use them in software architecture in order to A, inform decisions, or B, to talk about our systems and making sure that other team members understand um, what our applications do. Now, when we think about a software architect, I really wanted to kind of talk a little bit about career progression. Software architecture is, in a sense, one of those. It really maps back to a developer life cycle, right? So, if you were to read this chart, right, when you start off as a developer today, the scope that you have is more project specific. You're working on a project. As then you get into senior developer, a tech lead, the the problems that you are facing, the scope becomes larger. Maybe it's no longer a project that you're working on. Now you're working on several projects, or maybe you're working at a project that crosses across your company. But eventually, when you become a technical lead, usually, and I mean, this is, I'm making a generalization, but you're kind of usually, you have two main options to go with: a software architect or an IT manager. And this is where I think in your career, where you can kind of take a moment, or maybe I think now as you get into your career, and take a beat and understand that, are you a person that likes to lead people? Are you a people manager? And people manager usually, after tech lead, they become IT managers, eventually directors, and etc. But usually those are the people that are technical but want to have more distance between themselves and the code by managing people. So really they care about fostering their team members. Software architect is not like they don't care. They also care about fostering, but they do it in a different way. They do it through patterns. They do it through forums. They do it through guilds. And a software architect, and eventually you can become a principal architect, those are roles that we call them single contributor roles. Usually, a principal architect does not have a team. They usually have a sphere of influence. And the way that they influence is through tools, through principles, and through patterns, which we're going to talk about those three in this presentation. So once we eventually get to the software architect realm, the scope again becomes larger, right? Now we're going to be talking about organizational specific changes that you are working on. So maybe your project, where before had to scale to, let's say, 10,000 users, it may have to scale to 100,000 users. So that complexity of scope, you really start to feel it a lot in computer science, and especially when you're working in an organization. So I'm going to stop right here because I mean, it's a very simplistic view, but is there any questions so far on a role progression to become a software architect? Like I mentioned, we can put messages on the chat, or Shiki can definitely read them out for you, or you can come off chat and ask away.
Okay, so I'm going to go first. Based on what you just mentioned, in my understanding, if I understand it correctly, the tech lead is the person who lead a team and work on a specific feature, but software architect is not in a team. It's more like use his influence to manage multiple teams and to contribute to a whole picture. Is that right?
Yes, that's right, Chiki. A software architect can belong to a team. It really depends on the org structure of where you work, but usually the software architect is working across different teams. And again, if we go back to the principle where, software architecture is about, bridging the gap between content design, and business requirements, then yes, the software architect plays that more overarching role across different teams, like you mentioned.
Any
Perfect.
question from other people? I guess no. Oh yeah, there's one. So
Sure.
Brand said sorry if this was covered early. My audio wasn't working. So don't worry. What are the key difference between product manager and software architect?
That is a great question. So a project manager usually like very similar. They both may share the same scope, where a project manager is managing very similar a project or an app. The software architect is usually sitting in conversations with the project manager, and in order to turn business requirements into technical requirements. So the project manager is making sure that my team, they have anything they need to do. We are meeting all the deadlines. There's no bottlenecks. The product has a roadmap. The software architect is there to kind of help guide any kind of decisions, like we'll get to in our case study, that are going to influence the engineering or the intersection of design and business requirements of the team. And very quickly, we will talk about how we do that um, using principles. So when you're building an app, this kind of brings me back to when I was first building apps for the first time, the amount of information out there, it's phenomenal, right? I think never has before have we had so much information. But with so much information comes, what is the right information? How do I start? How do I know that I'm building my application the right way? How do I know that I'm building something that is good, that is scalable? Um, the way to always A good way to validate that is to have architectural principles that you're always referring back to. And what is an architectural principle? An architectural principle is a concept. It really is a way. It's a proven way that says, if you follow this design principle, you will achieve results that are certain results, meaning that we can repeat them. Common design principles that you may have heard are like separation of concerns, encapsulation, single responsibility, dry, do not repeat yourself. All these are architectural principles that allow us to, in a sense, make sure that when we're building something, we're building it to get to produce certain results. So what that means that if you use something like do not repeat yourself, right? When you're writing a piece of code and you take that module and you turn that piece of code into a module, and then you can reuse it across all your applications, suddenly you have created you have now part of the dry principle, right? And by doing that, you have made it much easier for the software to be maintainable and extendable. So all these principles, they always are meant to produce really good, like quantifiable results when we follow them. Now, like any good principle, you will find exceptions, but at least in my career, I have found that these are, the principles that, generally architectural principles are good to follow, and they're really good for to start to use them in your everyday work, even if it's very early on in your career. So let me give you an example of what that would look like. Um, for example, separation of concerns principle. This principle talks about separating a computer program into different sections or concerns. You could literally say that building a website follows separation of concerns, where you have HTML markup just for the markdown, CSS just for styling, and JavaScript just for interactivity. That means that you have separated the concerns of each each output into what it's doing. In this case, CSS is taking care of our styling. HTML is taking care of our semantic context, and JavaScript is taking care of our interactivity. That is separation of concerns. And these kind of principles become so important as you start writing more and more software, because a really good application only does one thing and does one thing well. Now, that can be challenged, right? There are many times where you're going to be building an application that is like a Swiss Army knife that does everything. But the idea of building with separation of concerns in mind means that you're more reusable and you're more scalable, right? As a good software architect or as a good developer, we don't want to write a lot of code, right? We want to write smart code. The less we write, the better, because the less it is to maintain. So the decisions that you're taking early on in your project are very important. The second one that I wanted to highlight for this team is encapsulation. Encapsulation is another design principle that really talks about, when you bundle data or when you make something accessible outside, there are layers to it, very similar to an onion. And object-oriented programming is a really good example of encapsulation, where if you want to share, let's say, a class, an object-oriented class, you have that class as private data that is not available to be written or read from outside of that class. But it has a public interface, meaning you can actually get into that class, usually with getters and setters. That is encapsulation. Now, if we were to think about encapsulation from a privacy point of view, right? And we say, okay, our customer data is encapsulated, right? It's in a database that does not has no API that can read. And then we build another service that can actually read from this database. So that's the same concept, right? Is always keeping it kind of follows in hand the least amount of responsibility. The idea is as as an encapsulated object, you want to tell the outside world the most minimum amount of information about your app or yourself. I mean, about the app or the class. Now, this is again important because then you can start to segregate what is important to the business, meaning, for example, customer data, no access to it, but you have a very easy way to get to customer data. Hence, public, protected, or private data. Another one that we kind of alluded to a little bit is called the single responsibility principle. In a design principle for separating a computer program, it really talks about separating into distinct sections. So there's this little joke, right? That is this, there's the Swiss Army knife that is for everything, right? And imagine that you build an app that does everything. It does like it's a Facebook, Instagram, TikTok, YouTube, all in one. You can do it. By all means, you can build it. As you get more and more users, you will find that it's harder and harder to maintain. Very easy. If I were to ask you, hey, one of these little tools, it's very oily, and every time I take it out, I hear a little squeak. You would have to take this huge tool, open each one of them, and see which is the one that is causing a little creak when you open it, and then oil it, right? It's the same thing with software. If you build, we call them monolithic applications that try to do everything at once, in a sense, it's a little bit like painting yourself into a corner, because then when you want to get outside and paint where you are, it becomes very hard. So the idea of single responsibility is when you build a function, when you build an API, when you build a module, make sure that you're building for one responsibility. So if it's a module that does analytics, it's only for analytics. If it's a system that only takes in marketing content, only marketing content. And delineating what kind of data can live in the systems, or what this function can do or can't do, it's very important. The last principle that I wanted to talk to you about is called DRY. Do not repeat yourself. And the idea here, as developers, we do not like repetition. We do not like repetition because we like to optimize, right? And that's in essence what computers do. So we usually replace repetition with abstractions, right? So for 1 second, take a look at the code to your right. Now, it's JavaScript, but even if it was any other programming language, it is very similar. One is a function for showing developers, the other one is a function for showing managers. They both have a loop. They both have expected salary methods. One has a get GitHub link, the other one has a get MBA link, and they each return the data set in a very similar way. So my question to you is, do you think this is a good example of not repeating yourself, or is a good example of not being dry? Or in other words, is there a better way to do this? Could we just write one function that takes either a developer or a manager, and then based on that, you call which method you want, right? That is the principle behind dry. Do not repeat yourself. So, any questions so far about the principles that we have talked about? I'm just going to do a little bit of a back forward. So we talked about not repeating ourselves. That means keeping our code and our practice, keeping our code simple, making sure that if we see duplications, we create abstractions. Second, we talked about single responsibility use. If you're going to build one function, make sure that it only does one thing. I would not want to see calculate infinity plus math function. I would like to see sum function, min function, max function, a function that is specific to what it is responsible for. Third, we talked about encapsulation. We talked about how it's very important that when you start building methods and classes, especially if you're working in object-oriented programming, where your modules are meant to be used by other people, you have a very comprehensible encapsulation model, which means what data you do not need to share. If it is, for example, if this is a class that is writing to a database, the fact that you're writing to a database, those credentials, you do not need to show. You encapsulate that. But getters and setters, you definitely want to show. And finally, we talked about separation of concerns, which really goes hand in hand with single responsibility, which is when you're building a system, every part of the system is going to do one thing and one thing well. And by separating the concerns, you can start to build and design a system that is, again, scalable and maintainable. So any questions so far before we move on from architectural principles?
Yes, there's a Patrick asked, I guess this is from like this previous section, but we're gonna address this anyway. So he asks, so a software architect needs to learn more than one tools or programming languages?
That is a great question. It is always best if a software architect knows more than one programming language. That being said, though, like it really, like if you learn one programming language, like one dynamic language like JavaScript, one object-oriented language like Java, that will give you a really good comprehensive of like two base languages, one dynamic, one static, one object oriented, one prototypical inheritance. So you kind of have both. But in my experience, the more programming languages you know, even if you don't know them to expert level, like just know them enough to be able to read the code of a developer, and just have a look at the code and understand it. Well, based on what you're seeing here, you could have not repeated yourself. Any high level understanding of programming languages in more than one, it's definitely always helpful, but not required, in my
I
opinion.
agree that if you learn more and you have more like background knowledge and you can handle the text better. And can you ask a question? So this is a good one. How does separation of concerns via single responsibility differ?
Yes, that is a great question. So they really almost go hand in hand. Single responsibility, it really works well when you're writing a function, you're writing a module, or you're designing an API, right? So really, you can say, for example, let's say we're building an API for a chat API. We know that our API only does chat, but then I'm going to take a step back. I also have another API that needs to do, there's a marketplace API, there's an analytics API, there's my chat API. And suddenly, we have to put them all together into one API, right? Let's call it, I don't know, customer API. Suddenly, even though I'm technically inside my API is following the single responsibility, which is my API is only doing chat, I started to I started to violate the separation of concerns, because now I'm bundling all my APIs, even though that each API is single responding into a monolith. So separation of concerns is really the way that I like to describe it. It's like the 10,000 foot view of your application. What is your application doing at the 10,000 foot view? Do you have one is your database? You have you have one API for your content. You have maybe a CDN for your cache, but that's separation of concerns. Single responsibility is what is that service doing?
I see. Like if you follow the single responsibility and inside your single responsibility API, you need to separate those concerns so that it's like one upper layer, and inside that layer you follow another design pattern, but they are not
Exactly.
separate.
Exactly.
Okay, yeah.
You start with single responsibility as your design pattern, where you're saying, like, yes, you're going to develop only to do one capability. Then the separation of concerns, this is the one step up, where hopefully your whole system, for example, the web, HTML, CSS, JavaScript, we know that every part of the web is separated for something. CSS is for styling, HTML is for content, JavaScript is for interactivity. So that is separation of concerns. Technically, JavaScript can do everything. You could literally build a website with only JavaScript or only HTML, but separating those concerns, that's the important part.
So you apply different design pattern at different scope, right?
Exactly, at different scopes. Exactly, at
Okay,
different.
good. Then I understand. So Peter has another question. How would you know which programming language is the best suited for your specific need without knowing them fluently?
Without knowing.
Knowing them fluently, knowing them well enough.
Yes. Yes, that is a great question, Peter. So probably the best way, it's a hard question. So it really kind of meant to be like, what programming language talks to you. You kind of have to fall in love with it, right? Like for me, at the beginning, it was Java. I really liked it. Then it became JavaScript. Then it became Python, and right now is Dart. Dart is kind of like, tickling my fancy. So one is like, as a developer, what do you like? What programming language speaks to you? The second one is, is that programming language that you're learning, does it have a good future? So going on Google Trends, for example, on like seeing if JavaScript, Ruby, uh, C++, like those keywords, are they being, do they have a good job and potential market? And then the third one that I would take to decide is, well, in my org where I work today, what are the programming languages that I can already encounter and learn from? Because usually the best way to learn a programming language um, is by doing it, is by being in the job and learning from a senior developer. So taking those three parameters, what is important to me, what speaks to me, what is the industry and the job career asking for, and what are developers or people around me using, those three, taking those three, that's how I have chosen which programming languages to use in my career.
Yeah, and I guess you also need to consider like the team, like what the
Yes,
developers, their opinion, like
exactly.
what they want to use and what they think would be the proper language to do this job. Because like different programming languages have different advantages, like pros and cons. Like object-oriented languages, there are like JavaScript. I don't know
Mhm.
that well enough, but seems like different. And other like functional programming languages. So you are dealing with different jobs, then you might need to choose the language be based on the material of that job.
Definitely, definitely.
Oh,
Yes. Like there's that kind of inner joke of like developer like sentiment, like some developers do have a better experience with other programming languages than some other developers, and that could be because of the programming language, like Shiki was mentioning. So yes, definitely, taking into account what developers are saying about that programming language is another very good data point.
okay. Yeah, so we still have one questions. So
Sure.
Brandon asks, how do you separate concern when using the same language for multiple concerns, such as using JavaScript for both front end and back end, or using Java or Python for a desktop application for both style and back end?
Yeah, so that's a very good question, right? So when we think of separating of concerns, like I put HTML, CSS, and JS here as an example. Usually, when we separate of concerns, we don't do it based on programming language. We do it based on functionality. Based on functionality. So what that means is, if we're building, for example, a website, this one, the WCB Design Agency, let's say it's a full stack JavaScript website, front end React, back end is Node.js. I still want to have separation of concerns. How do I do that? Easy, very simple. My first question is, do I have two code bases? One for the front end, one for the back end. Second, do I have, is my front end, they are going to be taking care of design, they're going to be taking care of accessibility, they're going to be taking care of analytics, of SEO. So all that has become part of the front end uh, experience. Now let's talk about the back end. I'm still going to be using JavaScript and I'm using Node, but those concerns are very different than my front end concerns. Those I'm going to be talking about caching. Do I need to have a form in case people click on this website? Do I need to have a site backup in case my website goes down? Those are backend concerns. So very simply, by just separating from front end to back end, even though you're using the same programming language, you have separated the concerns. So again, separating concerns based on functionality is always a rule of thumb?
Thank you.
Awesome. Great questions, everybody. Thank you so much for your questions. I really enjoy them because they also, invigorated me. Um, so now let's talk about common patterns, which is gonna get a little bit more more juicy. So we already know what an architectural principle is. We know what is software architecture. We know why it's important. We know that it takes in technical stakeholder requirements or business requirements and turns into technical requirements. Now, an architectural pattern, it is in essence something that is a general and reusable solution to a common problem. For example, if it is raining, our instinct is to take the umbrella and go outside. You could say that that is a pattern, right? And very similar in software, we have architectural patterns. The most common one, and the one I wanted to first start with, is called the three-tier architecture, where we divide an application into three tiers: database, application, and presentation layer. And each of those tiers now has, first of all, separation of concerns are there. Second, single user responsibility is there. And number three, every layer is taking into account one functionality. In this case, my database layer is making sure that all the data is accessible and is easier to read and to write. My application layer is taking all the inputs from my customer or from my user and putting them into my database. And my presentation, I have a UI that my customer or my user can interact with and eventually can write and I can persist data into my database. So that is one example of an architectural pattern that can help you a lot describe your application or start to design your application. Other ones that I won't talk about, but we'll talk about other ones: service-oriented architecture, SOA, or microservices. Those are again very common architectural patterns that you will probably hear about, and then really talk about the same three-tier architecture, but more on splitting it by APIs and by scale. So we'll put a pin on those two, but like I mentioned, on an architectural pattern, it is a super useful thing to have in your back pocket because these are solutions, proven solutions by the industry of problems that exist globally. So I'm going to take you through a few of architectural patterns. And at the end, like I mentioned, we can definitely take questions. The first architectural pattern that I wanted to talk to you about is called backend for frontend, or BFF. Now, the idea of a BFF is when you build a web application, you have an API for that web application. So if you would almost interpret this as each service has a web app, or each web app has a service. Why is this? What are the key features of this pattern? Well, first is it allows service A to be very specific to the web app A, service B to be very specific to mobile app B. So for example, I know that if I'm building a web app or I'm building a mobile app, they're going to have different UI requirements, right? Even the viewport is different. So having a service that I can fetch my data from and I can massage my data specifically for the needs of my either mobile device or web device becomes very powerful. And that is a pattern called backend for frontend. Okay. The second pattern I wanted to talk to you about is called the aggregate pattern. So the aggregate pattern is, let's say you do need to you're building a dashboard, or you need to build an app that actually talks to both services. So this is called an aggregator pattern, where you receive a request, and in essence, you you make a call to your aggregator, and your aggregator is going to call service A, is going to talk to database A. It's going to talk to service B, is going to talk and it's going to talk to database B, and it's going to combine the results. This pattern is very helpful if you need to show data and your data lives in two different databases. So common uses of this pattern could be reporting, could be dashboards, or could be some sort of reconciliation if you have multiple databases. If you have any questions on the patterns, you please feel free to like put the questions on the chat. The third pattern that I wanted to talk to you about is called the API gateway pattern. So you will, as you're working in tech and in development, you will stumble into something called API gateway. And what API gateway is, in essence, it acts as a way to, the way I like to describe it is almost like a bodyguard. A bodyguard at the layer 7. Layer 7, that means the networking layer, right? So that means that there's a bodyguard is standing right in front of your services and say, hey, do you have access to read the service? Or they can also, if you do have access, they can redirect you. So they are almost like the bouncer, right? So they can do two things. They can act what we call as a reverse proxy, or in a way as our bodyguard, and say, oh, you're not authorized to access this API. Or they can aggregate multiple calls. For example, let's say you're building a very famous app and is getting a lot of traffic. All the traffic is going to come into your API gateway. Eventually, it's going to hit a load balancer. A load balancer is a system that pretty much says, based on all this different traffic, I'm going to send it to different services, and so I don't crash. So the load balancer is smart enough to know that, if maybe service A is processing 10 requests, then I'm going to ask service B because they are not busy. So the load balancer becomes very important because it also allows your app to stay up in the case of becoming very popular, hitting the top news of Hacker News or on the front page of Reddit, right? Like a load balancer will save you. And then the last key feature is you can do a lot of cross-cutting concerns. What this means is, when you're building services, you have to do things like, when I mean a service, I'm talking about an API, right? A way to write into your database, either write data or retrieve data. You have to do things like authentication, tracing, logging, all these cross-cutting concerns. Instead of your service doing them, you move them up a level, technically up to a level to your API gateway. So then your API gateway is now doing all the cross-cutting concerns rather than your service. So that's the API gateway pattern. The last one, or the second last one I wanted to bring, it's called the CQRS pattern. Now, I really like this pattern because in my mind, it's a very easy pattern to understand. In essence, let's say you have two databases, and based on the data, you end up realizing that, reading data and writing data, they're both very different, right? Reading data from a database is not very expensive. You query a data, and maybe you get more and more complexity as your queries become longer. But writing data is a little bit more expensive, meaning that it's transactional. Think back to banking online. When you send money to somebody, or when you're receiving funds, you want to make sure that they do that right? You want to make sure that you're not, getting less money, or, hopefully you got an extra zero in your bank account by mistake. That's amazing. But mistakes like that should not happen. So the idea is you separate the concerns. You take your data and then you put whatever the customer reads more. Let's say you're building Reddit. All the news data will go into your read database. But then you have all the comments section where people are constantly chatting. So all your chat data goes into your write database. And each databases, they both hold data, but they're very different type of data. One is read data, which is just not transactional in nature, just the news. So that one we build is called a query service. Querying just means retrieving the data. The second service, we build a command service. That means we are literally writing a service in order to write to our database. So that's CQRS. Again, the last thing is like you can eventually build what is called a materialized view. What that means is that you almost, by doing this, you have very easy way to read different types of data and building these queries so you don't have to rerun your queries. So it can become very powerful and again, a very good pattern to follow because you can easily scale your writes if you have a lot of comments, or you can easily scale your reads if you have a lot of users on your top news. But by segregating the concerns, by having a single principal of responsibility, we have just made our service much more intuitive, maintainable, and scalable. The second last one I wanted to talk to you about is called the circuit breaker. So the circuit breaker, it is a very interesting pattern, but very similar to electricity. A circuit breaker says that, when we make a request to a service, if that service is not available, we're immediately going to tell our client, hey, that service is not available. And we're going to tell our load balancer to not go to the service at all. Why is that very powerful? It is very powerful because let's say you're building a website and suddenly your website goes down. A circuit breaker could help you by not keep sending requests to the service that is down. In essence, any request, the circuit breaker is going to literally break and is going to send to another service. So again, it is a really good mechanism. It's almost a fault prevention mechanism that allows you to bail early, fail fast, get out of there, and follow the path that you know is going to succeed for that request. So that is called the circuit breaker. And the last one that I wanted to talk to you about is called asynchronous messaging. Now, this one is probably one of the most complex patterns that exist there. But the idea of this asynchronous messaging is that everything your services are doing, so let's say they're writing to the database, they're reading to the database, they're updating, they're writing, deleting, but every action is put in a queue. In a queue, very similar to how you stand in line and you have a queue in the supermarket, you can query that queue and you can see all the different events that your services have done. Now, where it becomes very mind-blowing is that for any reason, if your database were to go away, you could technically replay the queue. And because it saved every single transaction, it's almost like replaying time. It will, using your services, it will repopulate the database with all those transactions, taking you to the last state before your data was not available. So asynchronous messaging is very powerful and something that you will eventually, stumble if you don't need to be, if you're not building transactional, but something that is called eventual consistency, which that means as long as the data is eventually consistent, meaning at some point in time you have the data there, you're okay. This is a good pattern to follow. So before I get into our case study together and we roll up our sleeves, do we have any questions so far about the different the different patterns? So like I mentioned, we have asynchronous messaging, circuit breaker, CQRS, API gateway, aggregate pattern, and backend for frontend.
So yes, so Brandon has one. So for aggregation pattern, what triggers the aggregator to be used vs just going straight to the database? Would it only be used when it receives a request involving data data with both databases?
Yeah,
What
that's a
is
great
it?
question. That's a great question. Yeah, so in general, it's like if you need data from both databases, right? And in most of the most common use cases are dashboards or reporting. Some sort of, you need to build a view of both databases and their state. That's when the aggregated pattern serves the best. When you need to represent the state of both of the data in both databases. And yeah, it's usually, it can be triggered by an HTTP request. It can be triggered by by I guess by a CI and CD pipeline. Like there are many ways to trigger this. Um, is mostly like if you're building a dashboard view or you're building a way that you need to collect and display data, then this is a good pattern to follow. Good question, by the way. Thank you.
Yes. Is there any other questions? Uh-huh. So if not, maybe we can go to, maybe I have one. We can go to the
Sure.
CQRS slide.
Sure.
Okay. So if I understand this correctly, you are trying to separate different functionality, so it can scale better, right? And
Correct.
you give us a example of Reddit. So like you can read the news, which is a faster operation. So we go to the query operation, and for comments, we use another database. But like we still want to show the comments on
Yes.
on the page. But so which means we still need to fetch data from the comment database.
Yes.
Yeah, so is that still a read query, right?
Yeah, that's a great question. So in this case, the command is only doing the write. So if we eventually will need to make another query service, so we have a query, a separate query service into that database that is optimized for querying data.
Okay, I see. So it doesn't violate. We just build one for the write, but we can still build another pipeline to just read for the
Yes,
same database. Okay, I see. Yeah.
correct, correct. The main idea there is like your query service, you can really optimize it for query. So you can do things like caching, you can do things like complex joins. You can start to build materialized views, like like an inner join, and you have like sorry, a table of a subtable. So you're just viewing that. So definitely querying, it can be query optimized. And yes, like to the example of this on the left hand side, you could have another arrow to query the data. But the idea is that you have a different service that is querying the data, and you have a different service that is doing there's a command that is doing the write to the data.
Okay, that makes sense. Thank you.
Awesome. Thank you, Shiki. Perfect, folks. Well, thank you so much for staying with us this whole time. For the last 10 minutes, we have a case study for you. And this is right now, you're all part of Nintendo. So hopefully we don't get sued. But hey, welcome to Nintendo. We are just launching our new Pokemon Go update. And for this case study, this is a user story that we have. Everybody in this room, you're all architects, right? So as an architect, you need to decide which database to use for the new Pokemon Go chat feature so that the engineering team can build the chat feature so that customers can trade Pokemons over direct message. Okay, so I'm gonna come off full screen a little bit so I can also see you guys. And in here, we kind of talked a little bit about, here we go. Oh, sorry, I'm gonna go like this. We talked a little bit about, what are some like little tricks and hints, but if anybody would like to kind of come off mute and tell me a little bit about, what do you feel about this user story? What are some little Easter eggs that we have planted here that can help us at the end of the day make our recommendation on which database to use for our new Pokemon chat feature? So yes, thoughts, questions?
Yeah, so I guess not all of you have a camera or microphone enabled. So if you need one, just send in the chat. I will grant that access to you. So let me take a few seconds to think about this question.
Yes. So I'm going to give you a little clue. So these are the 4 steps that we're going to follow as a team. The first thing is we have to understand and explore better the use case. But based on the fact that we need to decide a database, what are some things that we want to, we talked about databases a little bit. What are some things that we know about chat? Like just a chat in general. Is the data persistent or not persistent?
I guess the data need to be persistent because we need that. We need to trade Pokemon over direct message, right? Is that correct?
Yeah, exactly, right? So in a sense, we really want our gamers to trade. So it's a transaction, right? Like if we're trading Pokemons, right? If I'm giving you Charmander and you're giving me Bulbasaur, right? It's an actual trade. So that data needs to be persistent. And that data is also transactional in nature. Okay, so 2 clues: persistent and transactional. So let's explore a little bit deeper the use case. So Pokemon Go gamers are interacting more than ever with each other over direct message, according to our analytics teams. At the same time, we're seeing a decrease in trading and swaps at the Pokemon's in-game center marketplace. We believe that enabling trading over chat can lead to 4 times our engagement score and increase our daily users by 10%. I wish I'd worked at Pokemon. I'm kidding. But it sounds fun, right? It sounds fun to work at a place where you can trade Pokemons. But this would be a very similar use case, right? And you, as the architect, the decision that we have to make is like, okay, we understand that our customers, our gamers, are really not using the marketplace as intended, right? They're not trading Pokemons there. They are trading, they are chatting more than ever. So the idea is, well, let's bring the trading functionality to the chat. And and the assumption is that daily user increases by 10% and engagement score increases by 4 times. Now, these are made up numbers because this is a made up use case. but it is very similar to how you will be seen this use case in the regular world as a software architect. So let's a little bit let's so does anybody have any questions about our use case? I'm also going to see the chat here.
I have one. So, yeah, I understand this case, but I'm not sure like what kind of data structure you want us to design. I'm not sure if I understand this correctly.
Yes, yes. Okay, so very good. So before we even need to get into the type of data that we need, which amazing, Shiki, because you're already like 3 steps ahead. Let's just talk about the first step is to draw requirements. So we know our solution must work with a chat module. We know that very much like like Jim mentioned, the solution must be transactional and must persist. We know it must connect to a gamer's Pokedex, and we know it must connect to a gamer's wallet because there is a transactional nature to it. So, as an architect, you are building technical requirements off the business requirements. So, this is the business requirement. We
Okay.
distilled it to a technical requirement. Now, the engineering team is asking us, architects, what is the right database to use in order to store these transactions, right? In order to do that, we need to list in CQRS. You meant yes, definitely CQRS would be a really good option. Um, a really good option, Brendan, on the right pattern to use. Now, let me take you even a step back. There's something called ACID principles. When you're choosing a database, this is the best place to start. Every ACID principle is followed. It means the following. A stands for atomicity. It means that every transaction from a database is treated as a single unit, and it needs to have either guarantee succeed or failure. If you are in networking, this is very similar to TCP IP, right? There's a SYN ACK and a SYN ACK. So we definitely need atomic transactions in our Pokemon because our Pokemons are transactional in nature. C in ACID is consistency. Now, consistency means, does the data need to be consistent across all our different databases? The answer is yes. If I'm a gamer and I send, Brendan my Charizard, but it still appears that I still own it, well, we're starting to have a consistency issue. So consistency needs to play a part into our description. I stands for isolation. Does your data need to be isolated from your system? In our case, it doesn't. We're not storing any sensitive data. We're not storing our data is transactional in nature, and we're just storing the transactions that are happening as the customer is chatting. And D stands for durability. Does this data need to persist over a system crash or a power outage? The answer is yes, it needs to be durable. So we have just picked up a new principle called ACID, and we have now mapped requirements to that principle. Now, we can definitely take a step further. There's another principle, or another theorem called CAP theorem, which says of consistency, availability, and partition tolerance, which is fault tolerance, which is our last one, like durability, you can only choose two. And the reason why you can only choose two is because, according to the theorem, you cannot have a system that is infinitely available and consistent and partitioned across the world. So a lot of the choices that then we can choose is we definitely need our data to be consistent, and we need it to be fault tolerance. So that puts us as, CP, which that means you end up with this beautiful diagram. Now, there's many databases out in the world, but now we know that based on our requirements, we need data to be consistent. We need data to operate across network tolerance and across network outages. So we would choose some sort of database that falls inside this circle, consistent and partition tolerance. Now, the questions I would then ask my team or the team is like, okay, what is the structure of the data? Which is what Shiki alluded to. What database are you using now? How will the data be queried? And all these questions are markers for you on how to decide which is the best database for your system. So at the end of the day, you would end up with a recommendation uh, and what we call an ADR, an architectural decision record. And then we say, you know what, based on our recommendation, maybe CQRS is the best option. And we need, let's say, MongoDB because um, it's both available and sorry, I forgot. It's both consistent and available. Consistent and available. So in this case, we have now kind of used a little bit of some patterns to make an informed decision on a business use case. So any questions here? I wish we had more time to kind of go through the actual proper use case, but any questions on how we get from a high level use case, which is, you know, deciding what database to use so our users can chat and trade Pokemons. We understand the use case. We draw requirements. We map requirements back to principles, in this case, the ACID principle and the CAP theorem, and we end up with a decision or a recommendation on which is the best pattern and database to use based on our business use case.
I like the journey you just bring us through. Like we start from a business point, right? We know what we want, and you bring us to turn that into a software architect point of view. Like how do we achieve the business requirements? Like really using our development skill and the development knowledge, and then you introduce these ACID principles and the CAP theorem, and I really love them because the ACID principle really brings our back to earth. Like we think in the bottom like what we need, and in the CAP theorem we try to think like what's the most important feature we want, which is consistency and available. Because when you are when we are discussing, I was thinking because we want consistency, then we need a single endpoint, like a data structure. I was thinking about Brandon suggests like CQRS, but I was initially thinking about like backend for front end, like we all go to the single endpoint so that our data is gonna be consistent. But then I realized, okay, once we become so consistent, then we have like a single point of failure, right? So it's never perfect, but once you bring that CAP theorem, like so it's a trade-off. In the end, we just choose two of them and we make our final decision. I think this journey is really helpful for me. Like I never think about solving customer-based requirements on this level.
Yeah, exactly. Like you said, it's a journey, and at the end of the day, as an architect, you're doing that. You're doing trade-offs, right?
Yeah.
You can't design the perfect system, but it really helps to understand, like exactly, to take you through the journey of mapping those business requirements, using our principles, using our theorems, and then from there coming to documenting our decision. At the end of the day, like architecture is about making decisions. It's just making the best informed decisions we can. That's why we really stand in the in the shoulders of great people that have designed these patterns, these principles, but that we get to come in and kind of put our own spin and creativity on it. Um, so the last slide I have for you folks before we have the Q&A is and I kind of have community here twice, but when you go back to like when you leave us and Shiki, like you will find that architecture, there's a lot of tools. The tools may not be like an actual laptop or an actual piece of software, but the way that we have them is kind of like I have them as there's community tools. So we have architects have reference architectures or reference applications. These are generic like ways and guides on how to do things inside your orgs. Governance, as you can see today, right, it really plays a really big key into architecture because this is going to be a conversation with stakeholders, right? Like it's not going to be like, oh, we choose CQRS and MongoDB and away we go. It will be a conversation. So having an architectural decision record, which is what we just did today, but documenting that and then going through a technical review board to actually, present your option and present your solution becomes super important. And finally, another way that we still have community is architecture. We've talked about it high level, but you can also build starter kits. You can build templates that are a bit more suggestive of your architecture. For example, if you're building applications and you love building React applications, when create a React uh, uh, scaffolder just for you that follows the principles that you love. Maybe you love testing first. So that should be inside your starter kit. And the last one is architecture guild. Within orgs, there are architecture guilds that you can join, that you can be a part of, and you can see how architects talk. And they mainly, it's usually for architects, but depending on where you work, you can definitely go in. But again, all these tools are there to help us broach architecture again into business, mapping those business requirements, technical requirements, and marrying them to design and engineering. So that's all for me. Any Q&As? Okay, I'll give you.
Okay, we see Peter have a question. Would you agree that any programming language can be used for any of these architecture patterns, only difference being efficient operation and performance?
Yes, I would say, Peter, any programming language could be used for all these patterns. Obviously, you're going to find some are better than others, especially if you're talking about like databases, obviously, a programming, like you would not use JavaScript to write to a database, right? Unless it's like the web SQL in the browser. So there are programming languages that are better suited for some, but yes, but most programming languages you would be able to fit them into any of these patterns. And great question, thank you, and thank you, Laura.
Thank you. So is there any other questions?
I think we are just here in the thank you.
Oh, yeah. So yeah, if you are like, since we are here, Gonzalo, could you share your LinkedIn link in the chat
Yeah,
section?
I can definitely
Thank
share
you.
my LinkedIn. So again, if you have any questions, just feel free to message me on LinkedIn. Oh, we have a question from Jim. Where
Yeah,
does
Jim.
fit into software architecture? That is a really huge part of. So one part that we didn't really talk about is the software development lifecycle. in a software development lifecycle, it is more on how are you delivering the software. Now, when you talk about the SDLC lifecycle, that's where DevOps fits so well into the picture. Now, we have mostly talked about designing an application. So that's why DevOps was not part of the conversation. But then when we talk about designing the application and actually going through the actual pipelines of testing, QA, prod, all the way to prod. Yeah, like DevOps fits hand in hand with software architecture.
So I would view like architects as the person who design the product, and the DevOps is the person who implements the product. But of course, architect will involve, but it's mostly DevOps job to implement and validate and finally deploy, right?
Correct. Yes. So architect is usually more viewing and planning, and yes, DevOps are usually more on the implementation. So as an architect, you can say, I want to have making sure that every single pipeline has end-to-end test build. The DevOps team is going to now implement that build pipeline to make sure that every single app runs an end-to-end test. So they do go hand in hand.
I guess that answered Jim's question. Okay. Is there any questions, guys?
Don't be shy. No question is a bad question. How did you initially get started in architecture? Another great question, Jim. I guess I found it. It's okay. I started to get into one of my through my job. When I was a software engineer, I started working with a lot of software architects. So that was kind of my first exposure to software architecture. And then my biggest one was when I had to do a migration of Java to Angular at the time, Angular version 1. And there were not a lot of web architects back then. A lot of the expertise was mostly in Java and JBoss. So Angular version 1 and single page applications were very new at the time. So I was able to learn that very quickly. And one of my first jobs was at a place called TD Bank, leveraging Angular to use to build banking applications, and how I got into architecture.
Great
Thanks for the
experience.
question, Jim. It was a fun experience. Yeah.
All right. If there's no more question, we're gonna wrap up for today. But don't worry, you guys have the linking of Gonzalo. So if you have further question, please feel free to direct message him on LinkedIn. And yeah, so see you guys next time.
Thank you, everybody. It was great to all.
Thank you
Just to be
for
here.
being here.
Thanks, Shiki.
Have a
Thanks
great
for
night.
Thanks, everybody. Have a good night.